So we're going to start and talk about our counterfeit drug detection device and software solution. So it's been estimated that 8 to 15% of all medicines are counterfeit or fake, and that number in some of the studies, when you look at developing countries, can go up towards 30%. And so while this slide has a bit of the U.S. Focus with regards to how counterfeit drugs affect the U.S. market, in the developing country, we really see a much greater harms with deaths, drug resistance, and a loss of faith in the healthcare system. In the U.S. market, not only do we see the financial result of this, but one of the ways in which the counterfeit drugs enter the market is through the staggering number of mail packages that come through the International Mail Facility. And a very small fraction of those get inspected as they come through. So what you see here, this was published in the British Medical Journal Global Health, and you can see there's just over 40 different detection devices. Most of them are chemical in nature, and they go anywhere from looking at the packaging to full analytical testing. And so there's advantages and disadvantages of each of them. And, you know, one of the things that we look to do as part of this development is look at innovation opportunities. So when you look across the spectrum of different detection methods, there's some limited automation. Many require very costly equipment, which then requires some specialized training. And one of the components is there's multiple different types of detection with the inability to kind of extend to each other, and therefore that integration of data is something where we've built into our software solution. So this is what we've got. The box actually that you see here, it's approximately a half a foot in cubic direction, so not too big, and can be moved to different places in the sense that not only can we use a battery power, but we can also use full power. And inside the box, we've got a camera with 3 different light sources, UV, IR, and visual, a microcomputer, and a Bluetooth connection. So the microcomputer consists of a Google Edge tensor processing unit. It's quite powerful. It allows us to send the machine learning algorithms right to the box, which then, when connected through Bluetooth to our smartphone application, gives the opportunity for a reading on the whether something's counterfeit or not within about 10 seconds. So what we're going to show this in a short video demonstration at the end. And before we do that, Chin's going to go through a little bit more about the solution architecture and a bit what's underneath the hood.
Thanks, Karen. So you guys can see this screen. For our solution, there are 5 major components of there. The first one is, of course, the detection method, the box at the bottom left. And we have mobile phone as a bridge to communicate the information from the box to our backend system. And we have this integration hub to manage all the integrations requirements. And one of the things that you can see here is very interesting. We do have a box to integration hub connections. So the idea is to get the Internet of Things. One is to do the health check, to do the heartbeat check. And also with these connections, we were able to allocate where and when the box detects the counterfeit drug. So we can use the information for further analysis. And on the top left, you can see this is a cloud machine learning. So at this moment, our training is happened in the cloud. We're using Google AutoML Vision for one of the detection method training set. But also we have a local training as well using machine learning, deep learning, CNN module for one class classification. We'll talk more about that later. And also we have this IT system at the back end to really manage, kind of like a dashboard to manage the reporting as well as the training process and deployment process. So in this diagram, it's more dive into the detail. Our design is more towards the extensibility. So that means at this moment, as Karen mentioned, we're using the three light source, IR, visible, and the UV. So we have extensibility in our mind. In the future, you can see on the left bottom, we list a couple of things we're currently working on or we're going to work in the future. One thing is NIR. So at this moment, we can only detect the outside look of the peel. But with NIR technology, we can really look into the item, not only just the surface. And also, we're currently working with NASA technology. NASA developed this chemical detection chips in 2013. And with this chip combined with the laser technology, we can really vaporize a small part of this peel and detect the chemical inside of it. And also, we're working with our partner Form using other digital detection methods such as RF signals. To similarly as NIR, we're trying to get into the inside of the peel and to look at their digital fingerprints. And you can see all the information gathered from the detection method will pass on to this control board. The control board is a mini computer will control or pre-program the process. For example, how to flash the light, when we're going to take the image, and how to process the image. And also we have this edge TPU on board. So that means all the training set we can deploy directly to the hardware. We don't have to send, when you do the real detection part, you don't have to send the information back to the cloud and get the result back. So with the edge TPU, you can really run your TensorFlow process module on the hardware itself. And mobile phone is more like a control and bridge. So using the Bluetooth, so you can set up a Bluetooth connection, and the cell phone can control, we will show you later on in the demo. And also for the deployment, because this edge DPU, when we design it, we're thinking about put it into the environment which doesn't have the internet connection. So the problem is how to deploy the train module back to this board. So we're using the cell phone to really bridge the communication between the board and the cloud. So if after we train the module, we can deploy back to the hardware through the cell phone itself. So on the backend system, you can see we have database to store all the train models and all the transactional information. We have the console to manage the process of training, the training process, deployment process, and also reporting out of the box. So at this moment, we developed two prototypes for machine learning module. One is called one-class classification. So this CNN module actually is used for if you only have a real drug, right? You don't have a counterfeit drug for regular deep learning module. If you only have authentic drug, we use this module to train it. And if we find anything different of your detection items, we'll throw some report out of it. And the other part is the deep learning. Deep learning is running on the Google platform. It's called the AutoML. It's also a CNN module. And the difference between the one class and the deep learning is one class you only have authentic drug. But for deep learning, you have to have authentic drug as well as the counterfeit drug to train your model. So this is an example of our images we're taking and how we process it. On the left-hand side, we capture all the image in the box. You can see under different light conditions, the peel will show the different characters over there. And then after we take the image, we'll do the processing. The processing is really dive into the texture of this peel and also try to capture the imprint and the characteristic of the imprint as well. So after we process the image, the next one is to do the augmentation. The augmentation is to try to get every single angle of this peel from the single image. That means we're going to rotate the peel, and we're going to do the zoom in, zoom out to really mimic the real-time detection. So this is a process of how to do the Google AutoML training. It's fairly easy. It's a cloud-based solution. So the process involves the 5 steps. The first step is to do the data collection, and then we do the data labeling. So you have to label this image is authentic or it's counterfeit. Then we do the data augmentation, as we explained earlier. The next step is to do the model training. You can see the image in between. After you upload all the images to the Google platform, the training itself is just a matter of click a button, because AutoML itself already provides the best CNN model as you need it. So after training, we will use a cell phone, as we described earlier, to deploy this trained model back to the board through the cell phone. So this is 2 screenshots of our mobile phone capturing examples here. On the left-hand side, you can see, we're detecting a counterfeit drug, and there are 2 columns. You can see. Left column, it shows the authentic drug images for your reference. On the right-hand side, that's the detection object. So you can compare side by side. So in this way, we're simulating FDA existing CDX device. So we give a user visual to compare the authentic drug with the detected pills on the screen. And currently we have 3 light wavelengths to capture different characters. The first one is a visible light, and we have UV lights, and we have IR lights, and the bottom is processed images. You can see the texture and the imprint of the drug.
Okay, and just to summarize and bring everything together, so what we've described to you is a controlled integrated environment so that we can help increase accuracy of counterfeit detection. And using machine learning based recognition helps with standardization and productivity, so able to process in such a short amount of time. And with that, and as the increased information gets deployed, the counterfeit detection rules just continually improve. And with that, also, we're able to deploy that new and improved, continued improvement of a machine learning module back to each of these IoT devices, allowing just a real network of information that can be deployed both in real time and offline capability. And finally, and importantly, having a modular design for the future allows this to continue to improve over time. So either as kind of new technologies come online and or looking at some of the tried and true methods that are out there, such as the near infrared, that gives the power of software into the hands of those trying to stop the counterfeit drugs that are out there. It's just really important to note that there's just really huge financial incentive for those that are doing this. The illicit, it's actually more profitable than the illicit drug trade itself. And so we are hopeful, and as this prototype continues to evolve, that we can support the reduction of counterfeit drugs that are out there circulating out in the world. Okay, with that, we're going to move to a demo. We've got a video we're going to play. There is no sound to the video. Shin's going to narrate, so just so everyone's aware.
All right, so this is a box. It's a very small size, remote. You can move to anywhere you want. And when you do the real detection, you don't need the internet connection. And this is front side of the box, and this is side. You can see we have 3 power relay to control the lights and the operations of this box. And this is a back of the box. You can see one is a switch, the other one is the red buttons to do the pairing for Bluetooth. And this is side. You can see we're using micro computer. Here we need to deal with the heat. And this is a sliding door over here. You can slide up and see the compartments inside of it. And now I'm taking out the one pill. I'm using tongs for this demo purpose. Put the pills inside of the box, close the door. And this is my phone. And open up the application. and you can do the connection. Now I'm connecting to this box is through the Bluetooth, and I'm going to type in the drug I'm going to detect. For this case, it's Tom's, and then click the identify button at the bottom left. And the whole detection process will take about less than 5 seconds. And you can see the result is back, and you have all the images tied to it, and you can see the authentic tag associated with that. Now I'm going to put in another pill, which is we know is counterfeit, which marked with a UV light. From the front, you can see it's the same, but we're marked as UV light, and we're going to put it in. Close the door and switch back to the cell phone, and we click the identify button again, and the result will be back in 5 seconds. You can see the result is saying it's counterfeit, and also the image for your reference for visual comparison. And this is a UV mark, and I'm going to put in another real from outside looks really fake. Is I'm colored Tom's with green, and put it in, and do it again. Click identify, and the result will be back. So you can see on the screen, the left-hand side is image we took from during the detection.